Hello. Welcome to Grant Math. I'm just kidding. So, we have talked about 30, 60, 90, and 45, 45, 90 triangles in geometry, and we're going to discuss them again today as kind of a review because we need to make sure that you're all clear on really clear because these 30, 60, 90 triangles are going to come in again in the unit circle. So we start the unit circle on Monday. All right. So 45, 45, 90 triangle, as you know, has an x, and an x radical 2. Two sides are similar. It's like an isosceles triangle because the two sides are the same, congruent. And I've got we practiced this on Wednesday, so you guys are actually pretty good at it. 30, 60, 90 triangle looks like this. Opposite the 30 degrees is the shortest leg. So that's going to be x. Here's the order it goes in. X rad 3, and then 2x. So 2x is actually the largest side. X rad 3 is not the largest side. Because what's the radical of 4? What's rad 4? 2. So radical 3 has to be smaller than the 2x. All right. Then opposite the 60 is going to be x radical 3. That's the middle side. Opposite the 90-degree angle is 2x. Easy. We practice this. All right. Find x and y. Opposite 30 is y. Opposite 90 is 4. Opposite 90 is the 2x side. If 4 is 2x, what's x? X is 2. That means opposite the 30 degrees, this triangle is too high. Too high. It's too high, you guys. We need to shorten it. It's too high. And then what's opposite the 60? Someone else. 2 rad 3. So now what's going to happen is I'm going to do all of my 6 trig ratios. I sadly erased them for the quiz, but that's okay. And here's how it's going to be. I want to know for the acute angles. Notice how I'm focusing right now on acute angles. That means I need to do, ready? Let me write this first so you see what I'm doing. Sine 60, cosine 60, tangent 60, cosecant 60, secant 60, cotangent 60. And then I'm going to do sine of 30, the acute angles, the 30 and the 60. So I'm just writing it right now. Cosine 30, tangent 30, cosecant 30, secant 30, cotangent 30. Okay, ready? So I'm pretty sure that you can figure this out. Obviously, sine opposite over hypotenuse. It's going to be 2 rad 3 over 4, which is rad 3 over 2. So we simplify the things that are on the exterior. Radical 3 is protected. You cannot break that down. You cannot reduce it. It stays. Cosine 60 is 2 over 4. 1/2. Tangent 60 is 2 rad 3 over 2, which is just rad 3. This is way too cramped, so I'm going to spread it out a little better. Cosecant 60, reciprocal of sine. So it's 2 divided by rad 3. Which is going to end up being 2 rad 3 over 3. I'll just do the math for you. Secant 60, 4 divided by 2, which is 2. Cotangent 60, 2 divided by 2 rad 3, which I reduce to 1 over rad 3, which becomes, after I rationalize the denominator, rad 3 over 3. Okay. Now I'm going to do the 30 degrees, and you're going to see that things are going to be pretty cool. Well, all of math is cool, let's be honest. But there's a pattern. Sine 30 is 2/4, becomes 1/2. I want you to finish the rest. You can do it alone. You can do it with your people. Okay, I'm going to write mine in, and you can check as I go. Now I'm going to do all the steps because I need to go slow. 2 rad 3 over 4, rad 3 over 2. Tan 30, 2 divided by 2 rad 3. 1 over rad 3, rad 3 over 3. Cosecant of 30, 4 over 2 equals 2. Secant of 30, 2 divided by rad 3, which is 2 rad 3 over 3. Cotangent, 2 rad 3 over 2, which is just rad 3. Okay. Do you see any similarities right now between some of the 60-degree ratios and some of the 30-degree ratios? Can you just stare at it and analyze it and find any patterns, any similarities, and share some thoughts with someone around you? What's the same? What's coincidental? Any ahas, like, oh. Okay, so tell me what you noticed and observed. Nothing. Nothing was the same. They're all different. Come on, huh? Yeah.
And
Cosine 60 and what?
sine 60 are flipped when it's 30 degrees.
They're flipped when it's 30 degrees? Am I
Like,
pointing to the correct things? They're not.
Like cosine 60 equals to sine 30.
That's what I'm looking for. Yes. Tell me what else you see.
Sine of 60 and cosine of 30 are the same.
So I'm going to start drawing lines. And I'll do some colors to keep it all, Sine of 60, she said, was the same as cosine of 30. Then I got, Sabrina said, oh no, I'm sorry. Well, you both said those things. Okay. What else? Go ahead.
Tan of 60 goes to cotangent of 30.
Tangent of 60 goes to cotangent of 30. Cool. What are the other patterns? I'll do green and pink. Yes, sir. Cosecant 60 is equal to secant 30. Yup. Hey, what does 60 plus 30 make?
90.
Oh. Okay. There's literally two more. Secant 60 matches with what? Cosecant 30. Okay. I'm out of colors. What am I missing? Green, blue, red, pink. I don't know. Okay, what's the last thing that's connected? Cotangent. Okay, so all these connections. So what I'm going to do is we're going to continue on and we're going to directly talk about how these are matching up. Ready? Turn the page. All right. First off, I've got some 30, 60, 90. So here we go. Secant, right? So I've got P, angle P I know is 60 degrees. Yes? And so you're going to find secant of P and you're going to find tangent of P. So secant is hypotenuse over adjacent. Tangent is opposite over adjacent. So go ahead and do those. Okay. So I've gone and labeled them for you all ahead of time so that you don't have to put too much thinking into it. Okay. We're missing some sides. If I know that opposite 90 is 10, what's opposite the 30? What's right here? How high is my triangle? What's the height? If opposite 90 is 10, how high is my triangle? 5. And then opposite 60 is the x rad 3. 5 rad 3. Now, if I'm doing secant of angle P, that's going to be hypotenuse over adjacent of 60. So you go to 60, and I look at the hypotenuse of this triangle. It's 10. And then I look at the adjacent of angle 60. Adjacent is the right next to its side. That's 5. And tangent of P is opposite over adjacent. Opposite of 60 degrees, opposite of angle P is 5 rad 3. Adjacent is 5. And then reducing gets me what? Just rad 3. Okay. Cosecant of 45. Well, on example 3, I have to finish the triangle. I have to finish the sides. 12, 12, 12 rad 2. Okay. Then cosecant is going to be hypotenuse. So hypotenuse is 12 rad 2 over opposite. Now you're like, well, what 45 are you talking about? Well, it doesn't matter because they have the same, it's an isosceles triangle. Okay? So my opposite side of any 45-degree angle is going to be 12. So I'm going to put 12. And then I reduce that. All right. Cotangent 45. Adjacent over opposite. Adjacent to 45, they're both 12. Over opposite. 12, guys. 12 over 12. 1. Sine 45. Let's go to example 4. Opposite over hypotenuse. Let's label. Ooh. What are the side lengths of this triangle? The x rad 2 value is 10. Oh my gosh. The x rad 2 value is 10. So I need to solve for x. Divide by rad 2. Multiply top and bottom by the denominator that I'm trying to get rid of because it's a radical. 10 rad 2 over 2. 5 rad 2. Each side of my triangle is 5 rad 2. Over hypotenuse. So 5 rad 2 is my numerator. The hypotenuse is my denominator. The hypotenuse is 10. Rad 2 over 2. Am I going slow enough or am I going too slow? Part of the thing when I'm recording, I can't go that fast. Because what if the person watching this video 3 years from now needs it to, So, here we go. Secant 45. Hypotenuse over adjacent. It just becomes rad 2 after I rationalize the denominator. Okay. So we've got reciprocal identities. We're moving on. Reciprocal identities. And then I'm going to talk about the cofunction identities, and we're almost done. So cofunction is when I'm going to subtract like the 90 degrees. A reciprocal is going to be exactly what it says, reciprocal. The sine of theta is 1 over cosecant because sine and cosecant are reciprocals. So if I put 1 over cosecant, these two mean the same thing. Stop. Okay. Ready? This is a lot. You guys ready? My triangle is labeled ABC. So I'm going to go through and I'm going to write fraction ratios for the 6 trig functions. And I'm going to match them up. So like sine of angle A is side A over side C. Cosine of angle A is side B over side C. Tangent of angle A is side A over B. So I'm just doing the same thing. I don't have numbers. And then I'm going to do cotangent next. I'm switching it up a little bit. Of angle A is B over A. Secant of angle A is C over B. Cosecant of angle A is C over A. Okay. Then I'm going to do all of angle B, but they're going to match up, just like we saw on the front page. Sine of angle B is going to be B over C, which matches with that. Cosine of angle B is going to be A divided by C. That matches up there. Tangent of B is B over A. Cotangent of B is A over B. Those match up like that. Then I'm going to do secant of B and cosecant of B. Ooh, cutting it close there. Hold on. Secant of B is C over A. Cosecant of B is C over B. And those match up. And like we talked about, so do you have all that written down? And like we talked about over here at the beginning of the period, I would subtract 90 degrees minus whatever angle I know to get the other one. Angle A is 90 degrees minus B. Angle B is 90 degrees minus A. So I'm subtracting 90 to get that complementary angle, right? So I'm going to write this down. And I would recommend, if you're watching the video, that you let me write all this down and then you press pause to copy it down. That would be the smart thing to do. So please do that. Angle B is 90 degrees minus angle A. So I'm going to now show you some cofunctions. Ready? Sine of 90 degrees minus A equals cosine of A. So it's the angle measurement, right? 90 degrees minus one angle equals the other angle. 90 degrees minus one angle equals the other angle. Yeah. Oh, sorry. It's like, I don't know what's happening with my, it's not straight, or I'm like lopsided the whole video. And I'm going to run through all these. I'm just going to go down. Okay. So basically I'm saying like, okay, next cosine, hold on. 90 minus angle A equals sine of A. Again, I'm copying. If you're watching the video, let me do this and then press pause. Tangent of 90 degrees minus A equals cotangent of A. Cotangent of 90 degrees minus A equals tangent of A. These are cofunctions, you guys. Secant, you're just subtracting 90. 90 degrees minus A equals cosecant of A. Cosecant of 90 degrees minus A equals secant of A. Replace like A with theta, I could do that for like an angle measurement, any angle measurement. So I can use theta. Because I don't know the size of these angles anyway, so I can use theta. I said I wouldn't be recording till the end of the period. I'm sorry. I'm almost done. We're just subtracting on the next page. 90 degrees minus. Okay. Now I put on the top of the page for you these hints so that this would be easier to look at. Because like sine of 43 degrees means cosine, and I'm subtracting 90 minus 43. What's 90 minus 43? 47. Okay. Cotangent of 71 equals tangent of what? What's 90 minus 71? Okay, so that's what I'm doing. I'm subtracting 90, cofunction. Cosine of 27 is the sine of 90 minus 27. 63. Cosecant of 80 degrees is secant of 10 degrees. Tangent of 38 is cotangent of 52. Sine of 30 is cosine of 60. Cosine of 30 is sine of 60. Sine of 45 is cosine of 45. 90 minus 45. Tangent of 45 is cotangent. And secant is cosecant of 30. And that, my friends, is the end. Because this is just what we did yesterday. Find the missing sides. So, we're practicing this. You've got I photocopied it white. I don't have it handy, you do. So, on this page, we are practicing all of these 30, 45, and 60 for 30, 60, 90, and 45, 45, 90 triangles. Super easy. When it says the exact ratio, it means a fraction, okay? When it says an exact ratio, it means a fraction. All right, let me press stop. Yes.
I have a question.